Imagine searching for something, but instead of typing words, you ask AI a question, and it instantly retrieves the exact answer, even if those exact words never existed in the dataset. Or imagine uploading a photo, and in milliseconds, the system finds all visually similar images from millions, even billions of entries. This magic is not from traditional databases. It's powered by something newer, smarter, and designed for the AI era: vector databases. Today, we'll explore the invisible machinery behind AI search, recommendations, chatbots, and generative tools. And by the end of this video, you'll understand exactly why every major AI company, from OpenAI and Google to startups building RAG pipelines, depends on vector databases. What is a vector? Break it down simply. A vector is just a list of numbers, a mathematical fingerprint representing meaning. Examples: apple, the fruit; Apple, the company. Even though the word is the same, their vectors point in different directions. That's how AI understands meaning, nuance, and context. Mini visual example: cat, horse, dog clustered together. Car, bicycle, bus, another cluster. Cake, donut, pizza, another cluster. This is vector space. AI understands by comparing distances between these points. Why do we need vector databases? Traditional databases store things like hello world as string, 42 as number, SQL tables as rows. But LLMs don't think in strings. They think in vectors, thousands of numbers describing meaning. Pain points of traditional databases: can't perform similarity search, can't search conceptually, can't scale to billions of embeddings, not optimized for high-dimensional data, too slow for RAG-style retrieval. Vector databases solve this. They're built specifically for storing vector embeddings, performing similarity search, handling billions of records, scaling horizontally, running fast ANN, approximate nearest neighbor algorithms, powering RAG, personalization, and semantic search. How vector search works. Similarity search. Instead of searching exact match, vector databases find nearest neighbors, points that are meaningfully similar. Distance metrics used: cosine similarity, direction-based similarity; Euclidean distance, straight line distance; dot product, measure of alignment. ANN, algorithms. These accelerate search. HNSW, hierarchical, navigable small world graphs. IVF, inverted file index. PQOPQ, product quantization. Instead of scanning every point, ANN jumps through a graph or index like shortcuts in a city map. Real-world examples. RAG chatbots. LLM generates answer using facts retrieved from a vector DB. Flow, text, embeddings stored as vectors. Query converted to vector. Retrieve nearest vectors. Feed into LLM. Answer grounded in real information. Image similarity. Upload a picture. Model creates an image embedding. VectorDB finds similar images in milliseconds. Example, clusters of dogs, cats, cars, landscapes. Recommendations, user behavior, embeddings, compute similarity, recommend music, videos, products. This is how TikTok, YouTube, Netflix operate at scale. Fraud detection. Behavioral embeddings reveal anomalies that stand out far from the cluster. Popular vector databases. Pinecone. One of the most popular, fully managed vector databases used in production RAG systems. It's built entirely around one goal: make vector search fast, scalable, and effortless. You don't manage servers or clusters. Pinecone handles it. Extremely reliable for enterprise-scale semantic search. Powerful metadata filtering. Lets you mix vector search and structured filters like category equals tech. High recall accuracy, even with billions of vectors. Creators, startups, and companies building chatbots, RAG tools, search, or recommendation systems that must work at scale without infrastructure overhead. Weaviate. Flexible open-source vector database known for its hybrid search and modular ecosystem. Unique strength. It supports hybrid search, meaning you can combine keyword search, BM25, vector search, filters in a single query. Extremely powerful for real-world use cases. Fully open source. Easy to extend with modules. Built-in vectorizers. High performance for semantic search and filters. Teams that want control, open source flexibility, or hybrid search features. Milvus. One of the most mature and high-performance vector databases, designed for truly huge datasets, millions to billions of embeddings. Why it's powerful. Supports multiple ANN indexing algorithms, designed for distributed, large-scale deployments. Optimized for speed on high-dimensional vectors. You can run it on-prem or in the cloud. Perfect for enterprise-scale AI applications, e-commerce search, image similarity engines, social platforms, fraud detection, and more. High-volume projects and teams that need full configurability plus top-tier performance. FAISS Meta AI. Not a full database, it's a library, but it's extremely widely used, especially by developers and researchers. Very fast and memory efficient, ideal for local experimentation. Supports GPU acceleration for massive speedups. Lets you build your own custom indexing pipeline. Limitations. No built-in metadata, filters, or scale-out features. Requires you to design your own storage plus API layer. Prototyping, research, local experiments, or custom-made vector search engines. Quadrant. Modern open-source vector database with a great developer experience and excellent performance. Why Quadrant is growing quickly. Simple API, clean design, fast similarity search optimized for both cloud and local setups, strong filters, metadata filtering, and payloads. Quadrant Cloud for easy hosting works beautifully with RAG architectures. Balances simplicity, performance, and flexibility, making it ideal for small to large-scale systems. Teams that want an open-source Pinecone experience with strong performance and easy deployment. Chroma DB isn't a full vector database in the traditional sense. It's an embedding store widely used for smaller RAG applications. Very easy to use, fits perfectly into RAG pipelines. Popular in the LangChain ecosystem. Local first, runs quickly on your machine. Limitations. Not ideal for extremely large datasets. Limited indexing options compared to Milvus, Weaviate. Prototyping RAG, small apps, personal tools, or quick deployments. Vector databases are the backbone of the AI revolution. Every chatbot, every smart recommendation, every semantic search, every personalized user experience. And as models get smarter and data grows bigger, vector databases will become even more essential. Understanding vector databases means understanding the future heartbeat of intelligent systems. Stay curious, stay creative, and I'll see you in the next one.